11.2 using differentiation. We can remember that when we work in the previous chapters, S and T, this is displacement and type graph, and I'll draw, for example, this is 10 meter, and let's say this is T equal 5. Now, what is the velocity of this graph? So we work out gradient of ST graph is the velocity. So what is the gradient now? We can find this is 5, 10, this is 0, 0. So gradient we call velocity equal change in y over change in x10 minus 0, y minus 0, that is 2 ms minus 1. So what is the message now? What is the revision? When S and T graph, displacement type graph, gradient is the velocity. So what will happen if the graph is something like this? So this is displacement. The graph is a curve, something like this. Then how do you find the gradient? Or how do you find the velocity? So this velocity is constant, but this velocity is changing point to point, because in this point, if we find the gradient, we have to do a tangent, and we can find, so let's say when t equal 5, so this gradient is different from this point gradient, so it has a different gradient. It means velocity is changing along this curve. So what is the technique? We find the gradient, we simply differentiate in this curve. If s is given, v means ds over dt. Same as what is acceleration? What is acceleration? In a velocity time graph, if velocity is 20, the time is 5, then we know that acceleration is uh, gradient of vt graph. So what is the gradient here? So this is 520, gradient or acceleration is v change in y over change in x20 minus 0 over 5 minus 0, that is 4 ms minus 2. So what will happen if v and t, v and t, if the curve is instead of line, it's a curve, then how do you find the acceleration? Again, it's going to be it's a variable acceleration. The acceleration is different from this place. So if I need to find the acceleration of this point, so I want to find dv over dt, and then I need to apply when t equal, if I need to find this one, then a t equal 5, it means dv over dt when t equal 5. Now what is the summary? Summary is velocity means ds over dt, and acceleration is dv over dt. And I can express in terms of ds over dt. What is v? D over dt. Instead of v, I will drop this one, ds over dt. Then this will become d square s over dt square. So v equal ds over dt, or v you can write in two ways, dv over dt or d square over dt square. For example, assume we have a relationship something like that, 3t cube plus 4t square plus 5t. So find the velocity. So velocity and acceleration. Those two we want to find. So how do you find the velocity? V equal ds over dt. Just differentiate. This is going to be 9t square plus 4t 16t plus 5. So this is the velocity. Acceleration. Differentiate this one, ds over dt. Um, or differentiate one more time this one. So if v, so dv over dt, if in terms of v, or this is d over ds, ds over dt equal, so we are differentiating 18 plus 16. So if I rewrite this one, so what is this one? dv over dt, what does this mean? D square over dt square equal 18 plus 16. So what is this one called? E, acceleration. Let's discuss example 4. In example 4, a particle is moving along x-axis, and this is the displacement is given by this equation. The first question is find the velocity, and when t equal 3, we need v. Well, t equals 3. First of all, we'll find v. So v is dx over dt. It means v mean when you differentiate this one, 3t4, 32, that's all. So then when t equal 3, v is 3, 3 to the power 4 minus 32. Sorry, this is 3t, this is wrong. When you differentiate, this is 4t3. So then 4, 3, 3. So v equal 3, 4 minus 32. This is 4. So this value is going to be 76 ms minus 1. So if I explain again, so differentiate this one. So this is 4t3 minus 32. And next one is the value of t which we instantaneously as rest. Now, so it will come and it will rest in this place, part B. We want to find t when v equals 0. So we know now v equal 4t cube minus 32 2. So when v equals 0, 4t cube minus 32 equals 0, t cube equal 32 divided by 4, so t cube is 8. So t cube is 2 cube, t equal 2. When t equal 2, this the particle is at instantaneous uh, instantaneously rest. Now we need the acceleration. Part C, acceleration when p. So we want to find a when t equal 1.5. First of all, we need to find the acceleration. So acceleration means uh, dv over dt or d square over dt square, both same. Now we have either this one two times integration. So when you integrate one time, we will get this one v, and one more time. So a equal, I'll use dv over dt. So this is v value. Then a is 12 t square. Then we want to, when t equal 1.53 by 2, a we need a equal 12 3 by 2 square. So this is 12 9 over 4, that is 3 times 9, that is 27 ms minus 2. Let's discuss exercise 11b.